Here, we will solve a problem dealing with coffee cup calorimetry. In the first part, we're given the reagents and must find the overall balanced reaction. After determining the base and acid, we see that the hydroxide will react with the dissociated hydrogen ions to form water, while the potassium ions will join with the three phosphates. Since phosphoric acid is a polyprotic acid that can act 3 times, there will be 3 molecules of potassium hydroxide consumed and 3 molecules of water produced per molecule of phosphoric acid. Now, we have a fully balanced reaction. In the second part, we need to determine the limiting reagent. Using the volume and molarity, we can find the moles of each of the reactants. These reactants, though, are not consumed in equal quantities. Using the stoichiometry of the reaction from part A, only 0.12 moles phosphoric acid are needed to use up all of the potassium hydroxide. Thus, because there will be 0.14 moles of excess phosphoric acid, potassium hydroxide is the limiting reagent. In the third part, we need to explain whether the reaction is endothermic or exothermic given the initial and final temperatures. Because the temperature increases, we know that heat has been released, which means the reaction is exothermic. Lastly, we need to calculate the heat of neutralization in kilojoules per mole of water. Using stoichiometry from the reaction part A, with the limiting reagent found in part B, we see that 0.38 moles of water will be produced. Be sure to use the limiting reagent. Once the potassium hydroxide has been fully consumed, there will be extra phosphoric acid, but no more water will be produced. Next, using the density and initial volumes given, we can determine the overall mass of the solution. Now, with the formula for the heat of neutralization, we obtain an answer of negative 24 kilojoules per mole of water. Note that the heat of neutralization is negative for the reaction because heat is released. In this coffee cup calorimetry problem, we wrote a balanced reaction and found the limiting reagent to eventually calculate the heat of neutralization.